Welcome to Elements 101. Today we're going to be talking about thorium. On the periodic table, the symbol for thorium is Th. Its atomic number is 90. The atomic mass is 232.031. That's big compared to other elements. Thorium belongs to the actinoid family. When thorium is pure, it tends to be a silvery white metal. When contaminated, though, it tarnishes into thin air and turns gray, then black. Thorium, as I said earlier, is a metal. This beautiful element has 90 electrons and 90 protons, but it has 142 neutrons. Thorium is named after the wonderful and all-powerful Scandinavian god Thor, the god of war and lightning. Most of you know him as the Marvel character god with the hammer. It was discovered in Sweden in 1829 by a guy named Jan Berzelius. Thorium is a rare earth element. It is a natural element and a man-made one. Thorium is much more abundant in nature than uranium. Thorium's melting point is 2,115 Kelvin, or 1,750 Celsius. Its boiling point is 4,820 Celsius, or 5,093 Kelvin. That's really hot. No wonder it's named after Thor. Thorium is soluble in acids and reacts slowly with oxygen at room temperature. At higher temperatures, it reacts with oxygen more rapidly, forming thorium dioxide. The formerly widespread uses of thorium, for example, as a light-emitting material in gas mantles or as an alloying material in several metals, have decreased due to concerns about its radioactivity. It also can be used as a nuclear fuel through breeding to fissile uranium-233. Thorium is a component of the magnesium alloy called Mag-Thor, which is used in airplane engines. It's also used in an alloying agent in gas tungsten arc welding. There are so many other uses that I don't want to waste too much time on listing them, so let's move on. Let's look at some of the hazards of thorium. Thorium is a health hazard to humans. Exposure to an aerosol of thorium can lead to increased risk of cancers of the lungs, pancreas, and blood, as lungs and other internal organs can be penetrated by alpha radiation. Exposure to thorium internally leads to increased risk of liver diseases. Thorium is extracted primarily from monazite through a complex multi-stage process. Monazite is a relatively common form of beach sand, therefore you could be walking on part thorium. Oh, there's the bell, meaning it's history time. In 1829, Berzelius of the Royal Karolinska Institute, Stockholm, extracted thorium from a rock specimen sent to him by an amateur mineralogist. He had discovered it near Vrvuk and realized that it had not been previously reported. The mineral turned out to be thorium silicate, and it is now known as thorite. Berzelius even produced a sample of metallic thorium by heating thorium fluoride with potassium and confirmed it as a new metal. Thorium was first observed to be radioactive in 1898 independently by Polish-French physicist Marie Curie and German chemist Gerhard Karl Schmidt. Between 1900 and 1903, Ernest Rutherford, a New Zealand-born British chemist, and Frederick Soddy, an English radiochemist, showed how thorium decayed at a fixed rate over time into a series of other elements. This observation led to the identification of half-life as one of the outcomes of the alpha particle experiments that led to their disintegration theory of radioactivity. In 1925, the crystal bar process, or iodide process, was discovered by Anton Eduard van Arkel. a Dutch chemist, and Jan Hendrik de Boer, a Dutch physicist and chemist, to produce high-purity metallic thorium. Thorium, like uranium, survives on Earth because it has isotopes with long half-lives, such as the predominant one, thorium-232, whose half-life is 14 billion years. Thorium continues to be an enticing possibility for use in nuclear power reactors, though for many years India has been the only sponsor of major research efforts to use it. Thorium-232 was used for breeding nuclear fuel, uranium-233, for example, in the molten salt reactor experiment, or MSR, conducted in the United States from 1964 to 1969. Most of the initial test reactors were closed down. However, countries including Russia, India, and recently China plans to use thorium for their nuclear power, partly because of its safety benefits. Recent activities include the development of the Radkowski thorium reactor concept, being carried out by U.S. company Thorium Power, now Lightbridge Corporation, with Russian collaboration. You can find thorium in small amounts in most rocks and soils. It is mainly mined in Australia and produced in India. Oh, and they're also using it for some sort of car that I found this picture of when I was searching up thorium. Have a good day!